Quadratic Equations, Level 1. In the following series of videos, we will cover the various methods and techniques required to solve quadratic equations. Recall that a quadratic equation is an equation of the form ax squared plus bx plus c equals 0, where a and b are coefficients and c is a constant. In addition, a cannot equal to 0. A quadratic equation is a specific type of polynomial. It is also known as a polynomial equation of degree 2, or a second-degree polynomial equation. Lastly, it is also known as a second-order polynomial equation. All of these names describe the same type of polynomial. Notice that a quadratic equation tends to have three terms. The term ax squared is a quadratic term, or second-degree term. This term is the reason why this polynomial is quadratic in form. This is why a cannot equal 0. Because if a was to equal 0, this term will disappear and you're left with a polynomial that is not quadratic in form. Notice that this term contains a variable that is raised to the power of 2. Also notice that this is the term that contains the highest power of any of the three remaining terms. This is a telltale sign that you're dealing with a polynomial that is quadratic in form. In the same manner, the term bx is the linear term, or first-degree term, because the power on the variable x is equal to 1. Even though it's not explicitly shown, the variable is implied to be raised to the power of 1. And finally, the term c is a constant term, or the zero-degree term, because the power of the variable is equal to 0. And this results in x raised to the power of 0, which is equal to 1, which is then multiplied by the constant and signifies to the constant c. Quadratic equations do not always contain three terms. For the most part, there are three types of quadratic equations. They include quadratic monomials, such as 2x squared equals 0, quadratic binomials, such as negative x squared minus 4 equals 0, and negative 5x squared plus 2x equals 0, and quadratic trinomials, such as 3x squared plus 2x plus 4 equals 0. Notice that a common characteristic of each quadratic equation is the fact that there exists a term that contains a variable raised to the power of 2, and it's also the highest power that is found out of all the terms. Remember, this is the defining characteristic of a quadratic equation. Specifically, the polynomial must contain a power function of degree 2, in other words, an x squared term, and this power must be the highest out of the remaining terms. Now let's talk about the standard form of a quadratic equation. When solving quadratic equations, we tend to organize the terms in an order suitable for solving. We usually want to organize or rewrite the polynomial in descending order, and equal to 0. For example, the following quadratic trinomial is not in standard form. 4 minus 4x plus x squared equals 0. From left to right, the degree or order of each term is 0, 1, and 2 respectively. We want it in descending order, so we need to rewrite and organize it as follows. X squared minus 4x plus 4 equals 0. Notice that the degree is now written in descending order. From left to right, it's 2, 1, and 0. This is the form you want to organize all your quadratic equations before you start solving them. In the same manner, the following quadratic binomials are not in standard form. 5 plus 5x squared equals 0, and 9x minus 2x squared equals 0. The degrees of the first quadratic equation are, from left to right, 0 and 2 respectively. So we want to organize them with the degrees arranged from 2 to 0 respectively, as follows. 5x squared plus 5 equals 0. Likewise, the degree on the second quadratic binomial are arranged from 1 to 2 respectively. So we want the terms organized with degrees arranged from 2 to 1 respectively, as follows. Negative 2x squared plus 9x equals 0. And finally, for quadratic monomials, there is no need to organize it, since it only contains a term of degree 2, such as 2x squared equals 0. Alright, now let's talk about what it means to solve for a quadratic equation. Recall that when you solve an equation such as the linear equation 2x plus 4 equals 0, also known as a polynomial equation of degree 1 because the highest degree of the polynomial is 1, and linear because when you graph the left-hand side of the equation, you generate a line. Let's go ahead and actually graph it. Noticing that the left-hand side of the equation is nothing more than a line of the form y equals mx plus b, where m is the slope and b is the y-intercept. In this case, our slope is equal to 2, and our y-intercept is equal to positive 4. When you're solving any equation in algebra, you're actually trying to figure out where a specific function, in this case the line 2x plus 4, is equal to 0. In other words, where does it cross the x-axis? So looking at our graph, it seems that this occurs when x equals -2. So let's actually solve this equation using algebraic techniques as opposed to graphical techniques. So we subtract 4 from both sides as follows. Then we divide by 2 on both sides to solve for x, which ends up being equal to -2. This represents the point in which the graph of the line intersects the x-axis, specifically at -2, 0. Now let's actually talk about quadratic equations. When we graph quadratic equations, they usually have the following form. This U-shaped form is called a parabola. And just like the lines, which contain positive and negative slopes, parabolas can open upward or downwards. We will learn how to graph parabolas in a later video. For now, I want you to understand how quadratic functions look like when you graph them. Whenever you're solving quadratic equations or any equation in algebra, you're always looking for the value of x that will make the equation equal to 0. In other words, you're looking for the x-intercept of the function when graphed. Now this is where the similarities between lines and quadratics end. When we graph lines, they always intersect the x-axis once, hence linear equations have one solution. But when dealing with quadratics, you always have two solutions. The graph of quadratic polynomials can look like this, where the parabola can cross the x-axis twice, hence you have two real solutions. Or it can touch the axis once, like this. In this case, you still have two solutions. This is what is called a repeated solution. More about this later. And lastly, the graph of a quadratic can look like this, where it does not cross the x-axis whatsoever. In this case, you have no real solutions, but you do have complex or imaginary solutions. In either case, you always have two solutions when solving quadratic equations. So make sure you keep this detail in mind when we start solving quadratic equations. Alright. In our next video, we will start solving quadratic monomials and binomials. Quadratic equations, level 2. Alright, in this video, we will start solving quadratic monomials of the form ax squared equals 0, and quadratic binomials of the form ax squared plus c equals 0. Let's first learn how to solve quadratic monomials. The general procedure in solving quadratic monomials is to solve for x by getting rid of the coefficient a and then taking the square root of both sides of the equation. Let's show how this is done. Solve the equation 3x squared equals 0. Alright, anytime we are trying to solve for an equation, we need to follow a logical sequence of steps that would help us isolate the variable. In this case, we are solving for x. So we first need to get rid of 3. So we divide by 3 on both sides of the equation. 3 over 3 reduces to 1, and 0 divided by 3 reduces to 0. Next step is to get rid of the power. So we take the square root of both sides. The square root of x squared is equal to the absolute value of x, and the square root of 0 is equal to 0. So now we ask ourselves, when does the absolute value of x equal 0? Well, this occurs when x equals 0, and this is our final answer. If we were to graph the left-hand side of the equation, we would obtain the following graph. Notice that the parabola touches the x-axis once. This means that we are dealing with a repeated root, also known as a double or multiple root. Remember, quadratic equations always generate two solutions. In this case, we have a repeated root at x equals 0. This is why the graph touches the x-axis only once. This is probably the easiest type of quadratic equation you will ever get because every single quadratic equation of this form has 0 as its solution. So we are technically done with these types of quadratic equations. The key thing I want you to take away from this problem is the fact that whenever you take the square root of a variable squared, you end up with the absolute value of that variable. This idea is going to be important when we start talking about quadratic binomials. Recall that this is the definition of the absolute value. Specifically, that the square root of x squared is equal to the absolute value. You will be amazed how many students who start their first course in calculus forget or never even heard of such definition. So with that said, let's move along and solve quadratic binomials of the form ax squared plus c equals 0. The general steps in solving these types of quadratic equations is once again to solve for the unknown variable. We typically want to get rid of the constant c, then get rid of the coefficient a, and finally take the square root of both sides of the equation. Let's try the following example. Solve the equation x squared minus 4 equals 0. We first need to get rid of the 4, so we add 4 to both sides of the equation. The left-hand side of the equation signifies to x squared, and the right side signifies to 4. Now, Since the coefficient on x squared is equal to 1, we go ahead and take the square root of both sides. Doing that, we obtain the following. The square root of x squared reduces to the absolute value of x, and the right side of the equation reduces to 2. So now we have the equation, the absolute value of x equals 2. So now we ask ourselves, when does the absolute value of x equal 2? Recall that there are two solutions for these types of equations. The first is when x equals 2, and the second is when x equals negative 2. It's always a good idea to check your answer. So doing that, we see that 2 squared minus 4 reduces to 0. So that checks out. And negative 2 squared minus 4 also reduces to 0. Both solutions work. If we were to graph this equation, we would obtain the following graph. Notice that this parabola crosses the x-axis twice. Once at negative 2, 0, and once at 2, 0. Hence, the quadratic equation has two solutions. Another thing I want you to notice is that once again, whenever we take the square root of a variable squared, we obtain the absolute value of that variable, yielding two solutions. As a result, from this point on, I'm going to skip this step and use the following symbol, immediately after taking the square root of a variable squared. This symbol is read positive negative. This is a shorthand way of representing the positive and negative value of a number. So instead of writing x equals 2 and x equals negative 2, we write it in one line as x equals positive negative 2. Keep this in mind when dealing with this symbol. We actually have two solutions, the positive and negative of the number. Alright, let's move along and try the following problem. Solve the equation negative 3x squared plus 15 equals 0. We first need to isolate x by itself. So we subtract 15 from both sides of the equation, as follows, and obtain negative 3x squared equals negative 15. Next, we get rid of negative 3 by dividing both sides by negative 3. Doing that, we obtain x squared is equal to negative 15 over negative 3, which reduces to positive 5. And lastly, we take the square root of both sides and obtain the following. X is equal to positive negative the square root of 5. And this is our final answer. Remember, we always have two answers, and we use this symbol to represent the positive and negative square root of 5. This is very important. Many students forget to include the positive negative symbol and only get half the credit on their quizzes and tests, because technically, they only wrote one answer. So keep this in mind, and make sure you include the positive and negative symbol. Alright, let's try the next one. Solve the equation x squared plus 9 equals 0. Alright, we solve for x by subtracting 9 from both sides of the equation, and obtain x squared equals negative 9. Next, we take the square root of both sides and obtain x is equal to positive negative the square root of negative 9. Now, depending where you are in the curriculum, the answer is either no solution, because you were told that you can't take the square root of a negative number, or if you have covered imaginary numbers, this expression can be simplified as positive negative 3i, because the square root of negative 1 is by definition equal to I. Notice that in this problem, we ended up with imaginary numbers. So if we were to graph this equation, we would obtain the following graph. Notice that the parabola never crosses the x-axis. Hence, this equation has no real number solutions. But in theory, this equation must always have two solutions. In this case, they are imaginary, as opposed to real numbers. A quadratic can have either real or imaginary solutions, so don't freak out if you end up with imaginary numbers as your solution. It's completely normal. Alright, let's try the final example. Solve the equation 4x squared minus 9 equals 3 plus x squared. It seems that this problem looks ridiculously insane. Well, it's not that bad. All we have to do is to write it in standard form first. Then the equation can be solved similarly, like the previous examples. Let's go ahead and write this expression in standard form by collecting like terms. In other words, we get all the constants and variables in one side, and at the same time making sure we arrange the degrees in descending order, and leaving the other side of the equation equal to 0. It really doesn't matter if 0 ends up in the left or the right side of the equation. As long as it's in standard form, everything will work out. So let's go ahead and get all the terms to the left side. So we first subtract 3 from both sides and simplify to obtain 4x squared minus 12 equals x squared. Then we subtract x squared from both sides and obtain 3x squared minus 12 equals 0. Now we have it in standard form. Next, we go ahead and start solving for x. So we add 12 to both sides and obtain 3x squared equals 12. Then we divide both sides by 3 and obtain x squared equals 12 over 3, which simplifies to 4. Finally, we take the square root of both sides and obtain the value of x, which is equal to positive negative the square root of 4, which signifies to positive negative 2. And this is our final answer. So in this problem, our equation was not written nicely for us. We actually had to rewrite it in standard form first before we attempted to solve for x. So make sure you write it in standard form first before solving any quadratic equation. Alright, this is how you solve quadratic monomials of the form ax squared equals 0 and quadratic binomials of the form ax squared plus c equals 0. In our next video, we will learn how to solve a slightly more difficult version of quadratic binomials of the form ax squared plus c equals 0. Quadratic equations, level 3. In the previous video, we went over how to solve quadratic monomials of the form ax squared equals 0 and quadratic binomials of the form ax squared plus c equals 0. Now we will learn how to solve a slightly more complicated version of these quadratic equations, specifically quadratic equations that contain the sum of a variable and a constant squared. In other words, quadratic equations that contain the square of a binomial of the form a times the quantity px plus q squared equals 0 and a times the quantity px plus q squared plus c equals 0. These types of quadratic equations are solved similarly like the equations that we solved from the previous video. We can solve them by taking the square root of both sides of the equation. Alright, let's start with the first example. Solve the equation the quantity 3x plus 1 squared equals 0. Notice that this quadratic equation contains a binomial squared. So we can easily solve this equation by taking the square root of both sides. So we do just that and obtain the following. So here, remember that the square root of 3x plus 1 squared reduces to the absolute value of 3x plus 1, because this is the definition of the absolute value. Remember, the square root of a variable squared is equal to its absolute value. Next, we take the square root of 0, which reduces to 0. And now we need to solve the following absolute value equation. This equation is equivalent to the linear equation 3x plus 1 equals 0. So we subtract 1 to both sides and obtain the following. 3x equals negative 1. And finally, we divide both sides of the equation by 3 and obtain the final answer x equals negative 1/3. Notice that we obtained one answer. Recall that we always need to obtain two answers when solving quadratic equations. If we graph the left-hand side of the equation, we would obtain the following graph. Notice that the graph touches the x-axis at negative 1/3, 0, only once. This is an example of a repeated or multiple root of a quadratic equation. More about this in a later video. Let's move along and try the next example. Solve the equation the quantity x minus 1 squared minus 36 equals 0. First step in solving any polynomial is to write it in standard form. In this case, the equation is already in standard form. So we start by moving the constant to the other side by adding 36 to both sides of the equation, as follows. Doing that, we obtain the following. Next, we take the square root of both sides of the equation. The left-hand side simplifies to the absolute value of x minus 1, and the right side simplifies to 6. Next, we solve the absolute value equation. Recall that there are two answers, and as a result, we need to set up two distinct equations. One of them is x minus 1 equals 6, and the other is x minus 1 equals negative 6. So we solve each equation individually and obtain x equals 7 as one solution and x equals negative 5 as the other solution. Once again, notice that we ended up with two answers, as expected from quadratic equations. Recall that in the previous video, we skipped the absolute value steps and went straight to the answer by adding the positive negative symbol immediately after taking the square root of a number. From this point on, I would do just that and write the answer using positive negative notation, as follows. X equals 1 positive negative 6. Note that whenever possible, simplify the expression so that you explicitly show both answers. For example, this expression can be simplified as x equals 1 plus 6 and x equals 1 minus 6, which simplifies to 7 and negative 5 respectively. It's also a good idea to check your answers, especially during quizzes and tests. Let's go ahead and try the next equation. Solve the equation 5 times the quantity z plus 2 squared minus 125 equals 0. First step is to write it in standard form. Luckily, it's already written for us. Next, we need to get the constant to the other side of the equation, so we add 125 to both sides. Next, we need to get rid of 5. In this case, notice that 5 is being multiplied by the binomial squared. So we first need to take care of the 5 before we take the square root of both sides. So dividing both sides of the equation by 5, we obtain the quantity z plus 2 squared equals 25. The next step is to take the square root of both sides Doing that, we obtain the following. Z plus 2 equals positive negative 5. Then we solve for z by subtracting 2 from both sides, as follows. Then it's just a matter of finding both solutions, so we need to break apart this expression. One expression will be obtained by using the positive operator, and the other by using the negative operator. Then we simplify to obtain 3 and negative 7. These numbers represent the zeros or roots of the quadratic equation. Let's try the next one. Solve the equation the quantity x minus 2/5 squared equals 9 over 25. Notice that we have fractions in this problem, so don't freak out. For the most part, many students don't like fractions and tend to run away from problems that contain them. They're really not that bad. It's just a matter of remembering how to manipulate them. Notice that this problem is set up ready for us to take the square root of both sides, so we do just that. The left-hand side simplifies to x minus 2/5, and the right-hand side can be simplified by taking the square root of both the numerator and denominator, as follows. And this expression simplifies to positive negative 3/5. Next, we solve for x by adding 2/5 to both sides. Now, we need to add and subtract fractions. Remember, the way you add or subtract fractions is by first modifying the fraction so that they contain a common denominator. Then it's just a matter of adding or subtracting the numerator. In this case, both fractions have a common denominator, so we just add the numerators to obtain 5 over 5, which simplifies to 1. And for the second expression, we have 2/5 minus 3/5, which simplifies to negative 1/5. Alright, let's try the next example. Solve the equation the quantity y minus 2 squared minus 24 equals 0. This problem is already in standard form, so we add 24 to both sides of the equation. Next, we take the square root of both sides as follows. The left-hand side simplifies to y minus 2, and the right-hand side simplifies to positive negative 2 root 6. Remember, the way you simplify radical expressions is to first break down the number inside the radicand to its prime factorization. Then separate any perfect squares. In this case, we have 2 squared, which is equal to 4, which is a perfect square. Separating it and taking the square root, we obtain positive negative 2 square root of 6. Finally, we solve for y by adding 2 to both sides of the equation and obtain the following expression. 2 positive negative 2 square root of 6. Notice that we can't simplify this expression, like we did in the previous examples, so we leave our answer in this exact form, as opposed to a decimal form. Notice that we ended up with a combination of rational and irrational numbers for our answer. Keep in mind that these types of answers can and will occur when dealing with quadratic equations. Let's go ahead and try the next example. Solve the equation 3 times the quantity x minus 4 squared plus 12 equals 0. Alright, this equation is currently in standard form, so we first subtract 12 from both sides, as follows. Next, we divide both sides of the equation by 3 and obtain the following expression. X minus 4 squared equals negative 4. Now we take the square root of both sides. Doing that, we obtain the following. Here, the square root of negative 4 reduces to positive negative 2i. Remember, the square root of a negative number is equal to I times the square root of that number. The last step is to solve for x by adding 4 to both sides of the equation. So our final answer is 4 plus 2i and 4 minus 2i. Notice that we ended up with complex numbers as our solutions. Remember, quadratic equations may have real, imaginary, or complex solutions. Now let's end this video with a final example. Solve the equation 1/2 times the quantity 4x plus 3 squared plus 13 equals 3. This problem requires nearly all the techniques that we have seen from the previous examples. So let's start by solving for x by subtracting 13 from both sides of the equation. Simplifying the expressions, we obtain the following. Next, we multiply both sides of the equation by 2 to get rid of the fraction 1/2. Doing that, we have the following. Next, we go ahead and take the square root of both sides as follows. Here, the square root of negative 20 simplifies to 2i root 5. Or it could also be written as 2 times root 5 times I. Then we simplify this expression as follows. Next step is to subtract 3 from both sides. And finally, we solve for x by dividing both sides of the equation by 4. Doing that, we obtain the following. The quantity negative 3 positive negative 2i times the square root of 5 all over 4. We can also divide 4 to each term as follows. And simplify the second term as follows. Keep in mind that either form of the solution is acceptable. So it turns out that the solution to this equation is equal to negative 3/4 plus I times the square root of 5 over 2. And negative 3/4 minus I times square root of 5 over 2. and these crazy looking expressions are the solutions of this particular quadratic equation. Alright, in our next video we will learn how to solve specific quadratic equations by factoring.